Hey guys, this is Building Noob here with another video for CECS 225 lab. This time we're going to be doing our ripple carry lab. Let's go through this one by one real quick. So for this ripple carry lab, we're going to have a half adder module. Okay, obviously you make a new design, blah blah blah, and all that stuff. You guys know that. But here we're going to have two inputs. This is basically the base of the fundamental, foundation for our lab, which is to get two inputs and two outputs. So now we're going to do is gather one of the outputs or sum. We're going to do we're going to perform an XOR operation on the two inputs, and also a C variable called carryout, which we're going to dub carryout, and we're going to do an AND function on the two variables. Now what it's going to do is spit out those two, whatever they are. Why? So well, in this next module full adder, what we're going to do is cascade two half adders and sum, or take the wires of each couple wires here we have, and keep on passing it to each half adder. We're gonna have two half adders, which is gonna make a full half adder, right? Half and half is one. And at the end, we're gonna have an OR gate that tests the two wires that we take out, and another wire comes out, or we have another output in our wire. And so for this ripple carry, then we're gonna have four full adders. So remember, what this is just doing is we're adding 4 bits here. All right, so we have 2 bits in each one, and we're going to have 4 times to make it 4 bits. Okay, and we have to keep track of whether there's a carry out in any of the sum, in any of the sums, because if we do, then we have to carry that one to each of the next bits. Okay, so that's basically essentially what it does. These are being vectors. You're gonna have to do this 3 times and blah blah blah. So if we look at our schematic, let's generate a schematic real quick. Come on, open up. There you go. U2 real quick. Let's just see how this really looks like. Okay, let's pop this out and maximize it. Okay, and zoom out here. Okay, so here we have it. 3 inputs, and let's see if we follow one of these wires. Let's look at A. Goes to these OR gates, XOR gates, right? Keeps going here. Goes through C out, which tests for the outputs of these two. Follow this thing out. This becomes our C in for our B input in this next XOR gate, which becomes a C out. And if we keep seeing it, it keeps just going to the next adder. Just keeps adding and adding and adding, building and building and building. Okay, so that finally comes out C out. And if any of them had an extra bit in there, it would register as this last wire here, or this one actually, right, opposite way. It would register as this out C out, right? If it's a 1, if any of them is a 1, then it's going to C out a 1, right? Or if they're both 0, then it's just going to C out 0. There's no problem. That means there was no carry. But if any of them was a 1, then it's going to C out that 1. Okay, so that's our schematic. This is my second time testing this video because of this test bench that they want to run. So let's see if it runs this time. So here's the test bench code: CN, ABS, wires, C out. Now it's going to just call this ripple carry module. And we're going to do this for loop here 8 times, and all it's going to do is it's going to display, or it's going to randomize first what A and B values are going to be, and it's going to display them along with the sum and the carry out if it's any 0 or 1 of those two. 8's a hexadecimal for this 4-bit ripple carry. So let's see if we can this time run this simulation without any problems. Oh no, there's more problems again. So same problem I got last time. Okay, so all I can think of, yeah, look at this. Or maybe it's a process in here. No, that's the project. X simulation, maybe. Because there's nothing else in here that's, no, that's VM. There's nothing else in here that's that's the informational thingy. And these are just Windows processes. So the only thing I can think of that might be the problem would be this one. Let's end this task. Okay, it's gone. And let's try and run the simulation again. Maybe it might work. Don't know. Oh, it's going instead of throwing an error. I guess it worked. Well, it's going. But anyways, this is our test print code. So again, remember the replicator is going to be calling the full adder and the half adder. So it's not recursion, but it's something similar to that. You know what we see in programming. But anyways, our usual time scale of 1 nanosecond over 1 picosecond. So for this simulation, we're going to have to be looking at both the timing diagram and the console to make sure our answers correlate. Hopefully sometime soon. Oh, look at that. Oh, interesting. So it looks like it did work. So if anyone else in the world has that problem, there you go. I found you the answer. Anyways, so again, this was my second time recording this video because it didn't work the first time, and I've been having this problem. So I can't figure out what's wrong, especially because Dr. Nachawati gave us basically a code, and now we have to fill it in. And so she'll see when she looks at this video that I'm 100% sure that my code is correct, and the timing diagram still doesn't want to spit out 6 for some reason. I don't know why. But anyways, this would be a 6 here. These both would be a 9, so it'd be one of them. Okay, and that's basically it. Let's look at this console here to see where our values are. Maybe there's something different in here. Oh, that's weird. Where did it go? Should be in here. No, this is third run. I don't know where the answers are here. That's weird. See, this thing works in mysterious ways. Anyways, so this would just be all I would do is sum these. That's what this S would be here. Yeah, and it would see out a 1 or 0. So it'd either be up here or down here anytime the answer had to have a carryout. So here it would be 6, so there would be no carryout. It should be a 0. Here's a 9. Oh, and it won't go over what's the number again? 8 plus 4, 12, 16. It won't go over, right? It won't go over 15, sorry, 15. Won't go over 15. And okay. So there shouldn't be any carryouts here. At least not yet. Okay, until something like maybe even here. But even then. Anyways, that's what this project was. All there is to it. So, Professor, you can look at my code. See that there's nothing wrong with it. And for some reason, Vivado just doesn't want to give me the right answer. And now I can't even see it should display here in the console, and it doesn't even want to show that. For some reason. Nothing in the messages, nothing in the log. That's weird, because I was seeing all that stuff. I had this Word document open just in case, but it doesn't work. But anyways, that's all there is to it. Alright, hope you enjoyed this video. Remember to not dislike, but like this video. And subscribe, because I'll see you next time.